hopefully everybody's had an opportunity to go and try the quiz questions. Sam, I didn't really give you very much time to do all of that, but let's carry on with the more sort of difficult sorts of questions. When we are like on a Tuesday and on a Thursday in our first session, those are the majority of the questions in your papers. Okay, so those are the level 1 and level 2 type questions, which everybody is supposed to be able to do. This lesson now, or the second lesson on a Thursday, is specifically more difficult problems. Okay, so if you do find that these are really, really difficult, they're meant to be. Okay, so they are meant to challenge us, they are meant to make us think, they're not supposed to be straightforward. Let me just start my video. Sorry, I didn't realize I hadn't done that. They're not meant to be straightforward. So these are the more difficult sorts of questions. I just wanted to point that out again. All right, so here is a summary of all our arithmetic and geometric formulae that we've been working with so far. All right, so we know that any difference is calculated by saying term 3 minus term 2 is term 2 minus term 1. This over here is our arithmetic term formula, a plus n minus 1d. And here is our sum, or our arithmetic sequences, Sn equals n over 2 times 2a plus n minus 1d. R, we all know by now, is t2 over t1 equals t3 over t2. When we want to calculate a geometric term, we use ar to the n minus 1. When we want to calculate a geometric sum, it's a open brackets r to the n minus 1 over r minus 1. Be very, very careful. This is what I was talking about a little bit earlier. Okay, so here, can you see that minus 1 is in the exponent? Here, the minus 1 in our sum formula, it's not in the exponent. Okay, so that is a mistake that a lot of people make. And then the last formula over here, which should be familiar to you, but we haven't discussed yet, is our sum to infinity. Okay, but we'll talk about that next week. Let's have a look at the very first question. All right, so now here's something super unusual. Solve simultaneously for x and y. Okay, so whoever would have thought that they would have brought together a simultaneous solution together with sigma notation? It's something completely different. All right, so what we see here is two different equations. Equation number 1 is 3y equals 1 plus x squared. That matrix is equation number 1. We need to make equation number 2 from the information that they give us, right? Using our knowledge of sigma notation, all right? What is the sigma notation telling us? If we read it, what is it saying to us? What does it mean? Anybody want to have a go? Are you guys shy now?
Ma'am, can you ask the question again?
Yes, Khotatso, I'm asking you what I've highlighted in pink, what's in the middle of your screen at the moment. If you were going to read that, what does it mean to you? What are they telling you? Exactly. So this is the problem, because we look at that and we think, what on earth is going on there? All right. Can you see that this is actually very similar to what we were working with in our previous lesson? So when there was an equal sign, okay, over here, let me just point out the equal sign to you. So when there was an equal sign, all right, all of you said to me that on the right-hand side of the equal sign, whatever value was there, I'm going to highlight it now in green. Whatever number was sitting on the right-hand side over here, what was it in our previous lesson, the one that we've just finished? What did that represent?
A sum.
It represented a sum, absolutely. So it represented things that something added up to, all right? Then when we look at our sigma notation, what does the number at the bottom mean? The number at the bottom that I'm highlighting in orange. What does that mean? That's where
ma'am, that's the number at which the series starts, or the
exactly,
I don't know how
Lesedi.
to
So
say it.
that's 100%. What you've said is perfect, Lesedi. So that's where we got to start subbing in. Okay. What does the number at the top represent? The last number that we sub in. How would we work out how many terms are being added together to give a sum of 5y? How would we know how many terms there are? Again, we were just talking about it in our previous lesson. The number at the top minus the number at the bottom plus 1. Okay, so 4 minus 3 is 1. 1 plus 1 is 2. So in other words, there are 2 terms being added together to give us a sum of 5y. We're going to start by subbing in where k is 3. So we've got x times 3 minus 2 squared. That is the first term. The second term is going to be x times, I subbed in first with 3, now I'm subbing with 4. 4 minus 2 squared. The sum of these 2 terms is equal to 5y. That is equation number 2. Does that make sense, Matrix? So I'm using my knowledge and my understanding of sigma notation to help me make an equation. Is everybody happy with that?
No, ma'am. I'm not.
Okay, so where did I lose you? That's fine. Where did I lose you?
Ma'am, just from the beginning, ma'am.
Okay, so in other words, you want me to explain what this means again? No problem. Okay. So if they give us the sigma notation symbol and they tell us that there is a value at the bottom and they tell us that there is a value at the top, the number at the bottom is where we start subbing in.
Mm-hmm.
The number at the top is where we finish off subbing in, right? This bit in the middle over here is our rule. So the rule I've highlighted in yellow, that's the rule that we're subbing into, okay? So they want us to sub into the rule x times k minus 2 squared. And they are telling us that when we sub into that rule and we add our terms together, it is going to add up to a sum of 5y.
Mm-hmm.
Does that make sense to you?
Yes.
Okay. Now I need to work out how many terms are there in my sum. So I know how many things to add together to make 5y. All right, so I can work out that the number of terms in this particular equation on the left-hand side of the equation is going to be the number at the top, 4, minus the number at the bottom, 3, plus 1. There are 2. So in other words, what we've done here, Kotatso, is that there are 2 things that are being added together to give me 5y. Yes, okay. That's what it means.
Okay.
Okay. Now to work out what the first thing is, Kakeho.
Sorry, Lee. I just wanted to emphasize to everyone to substitute in the correct variable. Be careful, because if you substitute that 3 and 4 by x instead of by k, it's something completely different. So just emphasis to substitute at the correct variable.
Lovely. Okay, so Katlejo is just emphasizing to us, we have to substitute k is 3, not x is 3. We need to replace the k. So now when we sub into our rule matrix, we're going to write x open brackets. We must start subbing in at 3. So 3 is replacing the k minus 2, close my brackets, and then I square it. Does that make sense to everyone?
Yes.
Okay, and then after I've subbed in 3, what's the next number I need to sub into my rule?
4.
4. Exactly. So now I'm subbing in k is 4 minus 2 squared. And
So
now
ma'am,
I have, yes?
if n is equal to more than 2, is that how many?
Then you would know
Oh.
how many of these terms to add together to make 5y. Absolutely.
Oh, okay.
So if, for example, now they didn't do this, but if, let's say if, for example, they had put no, let's use something complete. Let's make it a little bit more interesting than that. Let's say they put a 7 at the top here.
Mhm.
Then how many times would how would I work out how many terms there are? I would say
Top minus bottom plus 1
is
is 5.
exactly. So then I would have 5 blue blocks that I need to fill, all being added together on the left to give me 5y, if that was the case.
Okay.
Okay.
So that will be your formula.
That will be
Okay.
your formula. Okay. All right.
Thank you.
So what you've got now, Katlego and everybody else, is you've got 2 equations. Let's just simplify this a little bit. 3 minus 2 is 1, and 1 multiplied by itself is 1. So 1 times x is x, right? So the first term actually has a value of x. 4 minus 2 is 2, and 2 multiplied by itself is 4. So 4 times x is 4x, and this is equal to 5y.
5y.
So what this means for us, matrix, is that 5x equals 5y. So what can I say about x and y? They must be equal to one another. So if 5 of x is the same as 5 of y, then the conclusion is that x and y must be the same. Now I'm going to solve simultaneously.
Sorry, ma'am, can you please repeat what you've said?
Where did I lose you in Jabulo?
Where you started by x plus 4x
Oh,
equals to
okay.
5y.
All right. So what I'm doing here in Jabulo is I'm just simplifying. All right. So I'm saying that I need to work out the value of the bracket, square it, and then times it by x. Does that make sense? So 3 minus 2 is?
1,
1. And 1 times 1 is?
1,
1. And 1 times x is?
1, x.
Is 1x. Yes. Yes. Lovely. Okay. So this blue block, that term has been simplified to x.
Yes, ma'am.
Okay. Now I'm going to do the same thing with the next term. So I'm going to say 4 minus 2 is?
2,
2. 2 squared is?
4,
4. And 4 times x is?
4x.
Beautiful. Does that make sense?
Yes, thank you, ma'am.
All right, lovely. Okay, so that's where I'm coming from. These are like terms on the left-hand side. So I'm going to add x to 4x, and I'm going to get 5x. So if 5x is equal to 5y, what this means for us, matrix, is that x and y are equal in this case. All right, and now what I'm going to do is I'm now going to sub, oopsie, I'm now going to sub x equals y into equation number 1. Exactly. So do you remember equation number 1? Here it is. Let's highlight it. Okay. Equation number 1 is here up at the top. Okay. I've highlighted it in blue. So what I'm going to do is I'm going to replace that y with an x. Okay, so if x equals y, I can now sub back in here and I can say 3 times x, because x and y are the same, is equal to 1 plus x squared, which is the rest of my equation. Now I've got to get it into standard form. So bring the x squared to the front. X minus 3x is going to leave me with minus 2x. And then I'm going to bring down my plus 1. Is that okay? Is everybody still with me?
Yes, ma'am.
Good stuff. Now I'm going to factorize. This is a perfect square trinomial, so it factorizes into a bracket multiplied by itself. So in this case, there is actually only one solution for x. X is going to be equal to 1. All right. And since x and y are equal, remember we worked that out over here. X and y are equal.
That means y
So
is
that
also
means
1.
that, exactly. So x is 1 and y is 1. There we go. And now we've solved simultaneously for x and y. Did you like that question?
No.
Oh, I'm sorry, Khutadso.
Ma'am,
But
don't you have
don't-
another example for questions like this?
Not like number 5. That's sort of like a one-off question. But you'd be able to find something similar to that. You see, the thing is that when it comes to problem solving, each problem is unique. And what it requires us to do is to apply what we already know and understand to what's been given to us. All right, so solving simultaneously is something that we learned how to do when we were in grade 11. And now what, yeah, exactly, solving for X and solving for Y. But now what they've done is that they've brought a metric concept, sigma notation, into what is originally a grade 11 sort of thing. Okay,
so
so
they must stop mixing things.
Oh, you're going to have to tell them. Now, this is another mixture, right? If you have a look at this question over here, this is another mixture of grade 10 and grade 11. All right, so let's have a look at this question now. Unless, is there anything you wanted to ask me? Are we fine with that now? Okay, all right. So now the next question. What is the greatest number of terms for which the series k plus 1, where k equals 1, up to n, will have a value less than 65? What does the 65 represent in this case? Is it an SN or is it a TN?
The TN.
It's actually a SN.
Ma'am, why is it an SN?
Okay. They are asking you to solve for n. And they're asking you to solve for n when the value of the sum of the series, remember sigma notation means sum, so the sum of this particular series has a value. So when they use the words has a value less than 65, they are implying that the value of the SN is 65. Okay, the English is difficult, isn't it? They're implying that the SN. Okay, so now, yeah, it's funny, hey? So now what we've got to do is we've got to manipulate what we know. Now, before, what we've done is we've always done this. We've said SN equals, okay, so if we're working with an arithmetic SN, SN over 2 times 2A plus N minus 1D. And we've subbed in over here.
65.
What they are saying to us here, Matrix, is that this SN, so in other words, this N over 2A plus N minus D, we must work out what N is when its value is less than 65.
Hmm?
So in other words, our SN is 65, but we're no longer doing an equation. We're now working with an inequality.
Oh,
Are these horrible? Okay, that's what it means. All right, so what is the biggest number of terms, all right, that can be added together that's going to add up to a value that is less than 65? That's what they're asking us. Okay, so we need to work out, is it 5 terms that add up to a number that's smaller than 65? Or is it 6 terms that add up to a number that's smaller than 65? Okay, that's what they're asking us to calculate. Difficult question, hey?
Oh, man,
Yes,
we must now
ma'am.
go open grade 11 books again.
Indeed, indeed. So this ends up being an inequality that you have to solve, and that comes from grade 11, 100%. All right, so when they say what is the greatest number of terms, the implication is we need to work out what n is. So we're definitely solving for n. So if we're solving for n and we know what the sum has to be less than, it means we need to know what a and d are, because we can't solve for more than one unknown in any equality or equation. So how are we going to work out a and d in this case? What do we do?
You still use that formula K.
Exactly, we still start by subbing in, don't we? Okay,
Yeah.
so in other words, our first term in the pattern, we're going to start subbing in where k is equal to 1.
1,
And then I've got to sub in
2.
2,
2, and then I've got to sub in
3,
3, and so onwards. Okay, so the first term is 2, the next
2,
term is 3, the
3,
next term is 4.
4,
Okay, so is there an A or is there a D or an R?
A D.
There's a D. Good. What's D equal to?
1.
1,
Lovely, lovely. Okay, so now subbing in here, I'm going to get rid of this A and I'm going to sub in 2. And then I'm going to get rid of my D and I'm going to sub in
1,
1. Okay, so now I've got n over 2, open brackets. 2 times 2 is 4,
4,
plus
1n,
1n minus
1,
1 is smaller than.
65,
Now, what can I do to both sides of my inequality?
Can't you divide?
Why do I not want to divide? I want to do the opposite. I want to.
2.
multiply,
That's it. Okay, you're going to times by 2, precisely. Okay, because you've got this divide by 2 over here, we always need to do the opposite. So on the left-hand side of the inequality, we're going to times by 2, and on the right-hand side of the inequality, we're going to times by 2. And there's no problem with us doing that because we're multiplying by a positive number. So this means on the left, we've now got n times 4 plus n minus 1 is smaller than, and 65 times 2 is?
130.
130.
Beautiful. Now I'm going to multiply out my brackets. So I'm going to get n times 4 is 4n, plus n times n is n. Exactly.
Minus
Minus
n,
n. And then I'm going to bring the 130 over to the other side, smaller than 0. And now I need to get it into my standard form. So n squared at the front, 4n minus n is 3n minus 130 is smaller than 0. And now you are back in grade 11 again. All right, let's just move these things out the way. I can move that down. All right, now we're back in grade 11 again, where we learned how to solve quadratic inequalities. Do you remember that? Okay.
Maybe so now you draw a graph also here also.
Yes, exactly. That's exactly what you do. So either you're going to draw a graph or you're going to draw a number line. So remember, when we're working with a quadratic inequality, And our graph is a happy face. And this one indeed would be a happy face because there's a positive 1 in front of the n squared, right? We are asking ourselves, for which values of n is our parabola smaller than 0? So for which values of n is our output or y numbers going to be negative? So our y numbers are negative below the x-axis. Does that make sense to everybody?
Oh, man.
Okay, so we need to work out what our critical values are, because these are the points at which output changes from being positive. So output is positive over here and over there, and it's going to be negative between. So where I'm shading yellow, that is where it is negative. Okay, so we're going to solve a quadratic inequality. So the first thing that we need to do is we've got to factorize. If we can't factorize, we can use the quadratic formula. All right? Do you want to use the quadratic formula or do you want to factorize? What would you prefer to do?
Quadratic.
Sorry, Nandi?
Quadratic formula.
No problem. All right, so we're going to write n equals minus b plus or minus b squared minus 4ac all over 2a.
Okay.
So our critical values are going to be when n is something or n is something else. So you can work out what those are. I'm going to do that too.
Wait,
And
ma'am, you know it's a smiley face by the arrow, right?
No, my darling, the arrow is what we are interpreting. You know that it's a smiley face because of what's in front of the n squared term.
Okay.
So if the number in front of the n squared term is a positive number, then it's a smiley face parabola. If there's a negative in front of there, then it's a sad face.
Okay.
Remember, Yebo.
N is equal to negative 13 or n is equal to 10.
Okay, so n is equal to, what did you say, negative?
13.
Okay, n is equal to negative 13 or n is equal to 10. All right, let's
Yes.
just get rid of that. Lovely, well done. Can n be equal to negative 13?
No.
No.
No. Okay, remember, n is your term number. We don't start counting at minus 13. It's got to be a natural number. So how are we going to disregard this answer? We're going to put a line through the
Line.
equal sign, and we're going to say, okay, where n was equal to 10. But wait.
You have to write it in.
We first got to test things. Okay. Now, this is what we're going to do, because we're not finished yet. All right. They said, what is the greatest number of terms for which the series will have a value less than 165? Okay. So now what I want you to do, Matrix, is I want you to do this. Okay. If n is equal to 10, subbing into Sn, we're going to say 10 over 2. The value of a in this case was 2. So the value of a is 2 plus 10 minus 1, and our difference was 1, wasn't it? Tell me what we get as an answer.
$65.
So we get exactly 65.
Ma'am, how many marks is this question?
Okay, so your marks would be for something like this. So a mark over there for interpreting SN is smaller than 65. There would no doubt be a number for getting a mark for getting it into standard form. Then either for factorizing, there's always an accuracy on the side for factorizing or using the quadratic formula. And now it's got to be on us working out the answer, but we're not finished working out the answer yet. All right. If I say the answer is 10, I'm wrong.
Yeah.
Ah.
Ow.
Exactly. Why? So go back and read the question. What is the greatest number of terms for which the series will have a value less than 65? Not less than or equal to 65, but less than 65. When there are 10 terms, Sn is 65.
Yo, ma'am, I'm lost.
So in other words, what we need to do is we need to go one back. All right. So the greatest number of terms for which Sn will have a value that is less than 65 is when n is equal to 9.
Right, man.
9. Okay. Remember, no problem. I'll explain it to you again. This is the trick in this question. Okay. When I say less than 65, am I including 65?
No, ma'am.
No, okay.
No, ma'am.
So exactly. So 65 is not included, all right? Because I don't have that underneath. So 65 is not included. So if okay, let me ask you a question. Tubile, tell me the biggest number, the biggest integer that is smaller than 5. What's the biggest integer that is smaller than 5? What? So let me write it down for you. What is the biggest integer that is less or smaller than 5?
4.99.
Ah, there we go. Coco and Sane, you've got the right answer. Good. You understand what I'm saying. Okay, can everybody see what Coco said?
Yes,
Oh, gosh. Oh, hang on a second, guys. I don't know where our screen went.
Biggest integer.
Sorry, guys, just 1 second. Sorry, we've just got some finger trouble here. Okay, can you see the screen again?
Yes, ma'am.
Okay, good. Okay, Lisa, come here. You asked a question. You want to ask a question? Go for it.
Miss, would it be wrong
Yes.
if 0 is smaller than n and by the way, n is bigger than 0 and smaller than 10?
Exactly. Okay, so n is not allowed to be 0 or anything smaller than 0. Right? So if I say to you guys, what is the biggest integer that is less than 5? I want you to name the integers. Where do integers start? Okay, with negative numbers. All right. So an integer would be something like -2, then -1, then 0, then 1, then 2, then 3, 4, then 5, and so onwards. So the biggest integer that is smaller than 5 is 4.
The biggest integer.
The biggest integer that is smaller than 5 is 4.
Yo, ma'am, why is it the biggest integer?
Because it's the one with the greatest value. Okay, so I'm asking you, what is the number that is the biggest that comes before 5? Okay. What is the biggest number that comes before 5? It's 4, the previous number. Okay, so am I including 5? No. Well, we weren't allowed to say 5. Okay, what was the biggest number that is less than 5? That number is 4. So it's the same story with this. What is the biggest number of terms that gives us a sum that is less than 65? Okay, if we have 10 terms then our sum is not less than 65, our sum is 65. So if we want to have a sum that is less than 65, we can't have 10 terms, we need to have 9 terms.
But if it said equal, then it becomes 10.
If it said equal to, then yes, then
Okay.
absolutely. All right, but they are saying to us, what is the number of terms we need to have so that Sn is a number that is smaller than 65? So when we work out that n is 10 when Sn is 65, we got to go one smaller because we want less than 65. Okay, so that's the final answer. N would have to be 9.
Hey, man, you make us cry for 4 marks.
Oh, I'm sorry. I'm sorry, Watobe. I didn't want to make you cry. That's the last thing I would want to do. Okay, but like I said to you in the beginning, so don't lose hope. These questions are the ones that are a lot more difficult. So in your question paper, in your final paper, you're only going to have one very difficult question. It's not like everything is going to be like this. Okay, it's just going to be one thing. So in a way, like it's nice for you to be able to do this because then it just gives you a little bit of exposure to problem solving and to just thinking about things in a sort of deeper way.
Yeah, but then it's mind opening. It's good.
It is, absolutely, absolutely, absolutely. All right, so now I want us to have a look at this question over here. So I'm just going to grab it and just move it over because everything feels like it's on top of one another here. Now, this question actually comes out of a past paper. All right, I can't remember which year, but it was something sort of fairly recent, 2020 or 2019. Or something like that. So one of the end of year papers that you guys are going to be writing at the end of this year, right? And look at what the question says. It tells us we're not allowed to use a calculator. Yeah, no calculator. Okay. And we have to and we have to work out the value of, and then look at that thing over there. All right, it's one sigma notation minus another one. So now again, we are applying our knowledge and our understanding of sigma notation to help us answer this question. What do we do when we see sigma notation? We start subbing in, don't we? And we start subbing in with the number at the bottom, and we finish subbing in with the number at the top. Okay, so in other words, what they are giving us, this actually, let's just get rid of this thing over here. This is going to end up being a long question, right? But we can make it a little bit shorter. Okay.
Sequences.
Yes, absolutely. So in other words, you've got this one over here,
and another one,
which is one pattern. And then you've got a minus in the middle. And then you've got another pattern on the right-hand side.
Okay.
So in other words, what you've got is a series of terms which have been added together. That's the yellow one. And then we need to minus another series of terms that have also been added together. Does that make sense to you?
Yeah.
Yes.
So this is a difference question. It's asking us to take a number, a sum, and minus another sum from it.
Okay.
Okay, that's what it's asking us to do. So let me rub out this thing that I put here. Okay. So now we've got an Sn minus another Sn. We've got to work out, is it an arithmetic Sn or is it a geometric Sn? Let's just get rid of the highlighters just so that you guys can see this a little bit. So we're going to work out whether it's a geometric Sn or whether it is a arithmetic Sn, right? So let's concentrate on the first term. Okay, we know that this is an Sn. All right, what we want is the number of terms. What's the number of terms in this one? How am I going to work that out? We've spoken about it a lot tonight.
Top minus
Top
plus
and bottom.
plus 1.
Okay, so there are 8 terms in our first, good Lisa Kanya and everybody else who said 8, there are 8 terms. Now let's work out what A is, and then we can work out the next 2 terms in the pattern and decide whether we're working with an arithmetic SN or a geometric SN. So now we're going to sub in. So our first thing we're subbing into 1 equals, we're going to say 3 minus 2. Then the next number we're subbing in is 4. Then the next number that we're subbing in is 5. Okay, and so onwards until we eventually end up subbing in
8.
10. 10. 8 will be the number of terms in the pattern. 10 will be the last thing that we sub in. Okay,
5.
so 1 over 3 minus 2 is 1 over 2. 1 over 4 minus 2, sorry, I'm talking nonsense.
1 is a 1.
It's a 1, of course. Sorry, guys. It's been a long day. Okay, the next one is going to be 1 over 2. Good. The next one's going to be
1 over 3.
1 over 3, and so onwards. Okay, so what is the value of A?
1.
Good. Is there an R or is there a D?
A D.
There's a D. Okay, so what's D equal to?
Negative.
2 over 3.
Okay. That's not what, hang on, that's not what I'm getting. I could be wrong.
We're getting a difference, right?
Hang on a second. Did we do something wrong here? So top minus bottom, 10 minus 3 is 7, 7 plus 1 is 8, okay? We're subbing in and we're starting at 3. So 3 minus 2 is 1. Then we go to sub in 4. 4 minus 2 is 2. Then we go to sub in 5.
Must.
Yeah.
Why did your minus change to a plus?
Why did?
Your minus change to a plus.
Where did my minus change to a plus?
Yeah.
In which line did I do that?
Started with 1 over 3 minus 2.
Yes. So the reason I'm doing that is because that's the rule that I'm subbing into. The rule I'm subbing into is 1 over y minus 2. Okay, so there's my 1, there's my y, and there's my minus 2.
But this is minus.
Okay, so now this is a sum of 8 terms that are being added together. Okay, and the last one is 1 over 9. Okay, now hang on a second. In this particular case, I don't think, yes.
Wait, never mind, ma'am.
All right. All right, hang on a second, because there doesn't seem to be a difference and there doesn't seem to be a ratio, right? So if I sub in the next thing, it would be 1 over 4. There's 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. Okay, I can't work with a geometric or an arithmetic SN.
And that's because I feel it's because we can't get T2, man.
Exactly. So there's actually no SN formula that we could use for this. Right? So what we're going to have to do is we're going to have to write that sum like this. Okay, now let's go and see what we're going to end up subtracting. Let's just go back to the middle. Okay, and from that we want to sub in, starting at 3, ending at 10. Okay, so again, there's going to be 8 terms in this pattern. And we've got to start subbing at 3. All right, so I'm just going to move over just a little bit. There we go. Right, so the first, okay, so does everybody understand that what we've got on the screen over here, highlighted in yellow, these are the 8 terms that we've got from this over here, from the sum of 1 over y minus 2 from y equals 3 to y equals 10. Then my minus is this minus over here in the middle. That's this minus over there. Now I'm going to work out what the first term in my second sum is going to be. So when I start subbing in here, I end up with 1 over 3 minus 1 is 2. How many terms are there?
8.
There are 8 terms. So what's the next term going to be? I started subbing in at 3, so now I'm subbing at 4. So 4 minus 1 is 3. Then I've got to sub in 5. Then I've got to sub in 6. Then I've got to sub in 7. Okay. After I subbed in 7, then I'm going to sub in 8. Then I'm going to sub in 9. And then I'm going to sub in 10. Okay. So now this is extremely long, like we had said in the beginning, right? But have a look at this. You've got, it's simplified for ourselves. Okay. We've got 1 plus a half plus a third plus a quarter plus a fifth plus a sixth plus a seventh plus an eighth. And from that we are subtracting, we're starting here at a half plus a third plus a quarter plus a fifth plus a sixth plus a seventh plus an eighth plus, I think there was also a ninth in this case. Yes. Let's just get that into the middle of the screen. Okay. What's going to happen to the sign of all the terms in the second bracket?
Going to change.
They're going to change. It's going to become minus, isn't it? So what's going to happen to the half in the first bracket minus the half in the second bracket? It's going to go away, isn't it?
Yes.
All right. And then this plus third minus that third.
Yes.
Okay. And then this quarter minus that quarter. And this fifth minus that fifth. And this sixth minus this sixth. And that seventh minus that seventh, and this eighth minus this eighth. And then remember, we're minusing all of these. So this is going to end up being a minus over here as well. So what are we left with? What's left over? 1 minus 9th. Okay, so the 1 comes from the beginning over here. And we are minusing a 9th. That's all that's left. Okay, so if we started with 1 and we took away a 9th, that's like saying 9 over 9 minus 1 over 9, we would be left with
8 over 9.
8 over 9. Clever question, or is that also horrible?
Yeah, it's mid.
The 8 over 9 is the answer to what?
Yes, so the answer is 8 over 9.
It's the
Okay.
answer.
That's the answer to the question. All right, so when we add, because what we were doing is we were adding numbers and then we were minusing another set of numbers, all right, that we added together. All right, so it was a sum minus a sum. A sum minus a sum. Okay. Are you guys feeling exhausted now?
Wait, ma'am. Why is it
Yes.
9/9?
Because when I want to subtract fractions, the denominators have to be the same. So because they told me that I wasn't allowed to use a calculator, what I've done is I've said, well, 1 is 9/9. 9/9 is 1. So I've made the denominators the same so that I can keep the denominator and then subtract the numerators, which is what I need to do with fractions.
So, ma'am, is this how we calculate a sum minus a sum, like every time when they give us?
In
Like
this particular case, yes. In this particular case. So here, what we found is that if we try and apply a geometric sum formula, it doesn't work. If we try and apply an arithmetic sum formula, it doesn't work. So we can't use an SN formula, right? Because there isn't a difference and there isn't a ratio. So what we've had to do is actually work out what all these terms are and then subtract what all the second set of terms are going to be. All right, so it's actually a clever pattern because I'm going plus, minus, plus, minus, plus, minus, plus, minus, plus, minus, and then I'm just subtracting whatever is left. Peterson, what would we have done if there was an SN and TN? Did you mean what would we have done? So what you could have done, let's say if it was possible to write this as a rule, what you could have done, Peterson, is you could have worked out the sum 2, so this is 8 terms, minus the next sum, sorry, I'm writing an 8 instead of an S, minus the next sum to 8 terms. Okay, so what we can do is that sometimes we can have we could have a geometric SN minus an arithmetic SN, or I could have a sum to infinity, which we haven't spoken about, minus an SN. They could ask us a question like that as well. So we were having to combine sums together as a difference. Okay, so they could do that. So they could use a geometric SN and they could minus an arithmetic SN from it. We're just asking for the difference between two numbers. All right. So in this case, there was no formula for SN because there was no ratio and there was no difference. Okay, Matrix. Okay, will you be pleased? You'll be glad to know that that is the end of your torture session.
Ma'am, we're still going to have to
There's
practice.
also a quiz for you to do if you want to. So there's an advanced quiz as well. Oh, you're supposed to do it. But I don't know how you're feeling by now.
Oh,
Have I killed you, Tobile?
yes, ma'am.
Oh, I'm sorry. I'm sorry. Is this making sense to you though?
Yes.
Okay,
is.
you sure?
Yes, ma'am.
Okay, guys, are there any other questions that you want to ask me?
So,
You sure?
yes.
Okay.
Yes, ma'am.
All right. Thank you so much for being so wonderful and for asking lots of questions and participating. I hope that you found this helpful, even though it was a little bit challenging. It's always a good thing for you to do problem-solving questions. Okay, but just remember, this is not the majority of your paper. What we did tonight is only 15% of your paper. Okay, so if you understood that only 15% of your paper is going to be problem solving. Okay, so don't feel discouraged by these sorts of questions. They are designed to be difficult. They are supposed to be difficult. All right, if you understood what we did in the previous lesson and it was fine, all's good. Okay.
Sure, man.
Thank you, babe. Even though it was easy, thank you.
It's a pleasure. It's an absolute pleasure. Thank you for being so wonderful. Okay, Matrix, we can say goodbye. You can go and try the quiz now if you're feeling up to it. Okay.
Bye, everyone.
All right.
Bye.
Okay. Bye. See you on Tuesday.
Bye.
Have a good week. Well, weekend. Bye. Bye. It can make a difference. 15% can make a difference. Yes.
Hold on, hold on.